Hey guys, and welcome back for another lesson on surds. I hope you joined us to our previous lessons on an introduction to surds and simplifying surd terms, as well as adding surd terms to simplify surd expressions by grouping, because today we're moving on to multiplying and dividing surd terms. If you missed those lessons, please check the description box down below so that you can get yourself caught up. Otherwise, let's get started. First, let's start with the rules of surds. You should have seen some of these before. For example, you should be able to add and subtract like surds. That is when you've got the same number underneath the square root sign. So a root b plus c root b will simply add together the coefficients, that is, the numbers in front of the rooted terms. So that's going to be a plus c root b. Today we're going to look at multiplying irrational expressions, so multiplying square rooted terms. So square root of a times square root of b, for example, we'll simply multiply the two irrational values together. So that's going to be the square root of a times b. We've seen something like this before when we were simplifying surd terms, but we went a little backwards there. The square root of 18 is the same thing as the square root of 9 times 2. So I've split the 18 apart into two separate values that are being multiplied together. Now I can take this square rooted value and split it into two separate terms. That's the square root of 9 times the square root of 2. And the reason we did that was so that we could rationalize part of this surd term. The square root of 9 is 3, while the square root of 2 remains irrational, so that stays under the square root sign. We can also square irrational expressions. That is, we can square square-rooted values. Square root of a times square root of a, for example, is clearly the square root of a squared. Multiplying any value by itself gives you that squared value. The nice thing about squaring irrational expressions is that the square root of a squared will cancel itself out. That will become just a. Today we're going to be looking at multiplying surd expressions together with both rational and irrational parts. So for example, a root b times c root d. As we've seen before, we can multiply the two irrational parts. So root b times root d will simply be square root of bd. But we can also multiply the rational parts together. So a times c. Altogether, that makes ac square root bd. And surd division, which we'll also look at today. The square root of a over b is the same thing as the square root of a over the square root of b. So those are the general rules of surds, and we're going to put those into practice today. You may want to take a minute to copy those down, and when you're ready, let's go on. Although surds may be new to you, I'm hoping you have previous experience with multiplying algebraic terms together and multiplying fractions together. Because if you can do that, we can relate those skills over to surds as well. Because much like with algebra or with fractions, we can multiply these two terms together even though they didn't have the same variable. I simply do number times number, so 2 times 3, and letter times letter, so x times y. So that gave me 6xy. Simple. Similarly with my fractions, I don't need a common denominator to multiply fractions together. I simply do top times top, so a times c, over, and then I do bottom times bottom, b times d. So that gives me a numerator of AC and a denominator of BD. Hopefully that's pretty straightforward and simple. So looking at our first example here where we're multiplying two surd terms together, I'll multiply the rational parts together, so 4 times 6, and I'll multiply the irrational parts together, so I'll multiply the 5 times the 7. So that's simply going to be 24 times the square root of 35. Just as we multiplied surds together, we can divide surds by simply dividing the rational parts and dividing the irrational parts. You might find it easier to do this if you write your divisions as fractions. Here I can clearly see that the rational 4 is over the rational 2, so I'll do 4 divided by 2. And I can see that the irrational square root of 3 is over the irrational square root of 3. So I'll do square root 3 divided by square root 3. As we've seen before, if you've got a square rooted value divided by another square rooted value, we could write those together in a single fraction that's being square rooted. So square root of 3 over the square root of 3 is the same thing as the square root of 3 over 3. So now looking at my rational fraction here, I've got 4 divided by 2, which is 2. Looking at my irrational fraction, I've got the square root of 3 divided by 3. 3 divided by 3 is 1. So this simply gives me 2 root 1. And we can simplify this a bit further. You should know that the square root of 1 is 1. So that would simply be 2 times 1, which is 2. Make sure you always simplify your surd solutions as much as possible. So when I'm multiplying the square root of 6 times 5 times the square root of 2, although I have two irrational terms here, where the number under the square root sign is not the same, when I multiply it out, I might notice something. So again, we'll do rational times rational. We've simply got the 5 as the rational number, nothing to multiply it with, so simply 5. And irrational times irrational, so we'll do 6 times the 2. So I've got 5 root 12. Most people would stop there, not realizing that we can simplify this irrational part. Remember when we simplified surd terms? By splitting the square rooted value into a squared factor and a non-squared factor? Well, 12 could be written as 4 times 3. And 4 is a square number. So this ends up being 5 times the square root of 4 times the square root of 3. But the square root of 4 is 2. So that's 5 times 2 times root 3. I can multiply my rational parts together now. 5 times 2, that's 10. So my final simplified surd result is 10 root 3. Let's try another one and try and get a bit more interesting this time. So I've got two surd terms, and both those surd terms have both rational and irrational parts. So we'll start the same way as always. We'll do rational times rational and irrational times irrational. 4 times 2 is 8, and 18 times 8, well, that number is going to get quite big. So let's first look at this and see if we could simplify it at all before we multiply it out. 18, I know, is the same thing as 9 times 2, and 9 is a square number. So let's split that apart and start rationalizing that irrational part. So that's going to be 8 root 9 times 2 times 8. Now the square root of 9 I know I can do. And 2 times 8, well, that's 16. 16 is also a square number. So I could actually square root both of those values. This ends up being 8 times the square root of 9 is 3, and the square root of 16 is 4. That's 8 times 3 times 4, which gives me 96. Although I started out with two surd terms, with irrational parts, with different numbers under the square root sign, my answer still simplified down to a single rational number. So watch out for that. Always look for ways to simplify whenever you can. You should always recognize that when you square a square rooted value, this will always make them rational. For example, 14 root 8 times 2 root 8, while we're doing our rational part multiplied by our rational part and our irrational part multiplied by our irrational part, you should notice that you're multiplying the square root of 8 times itself. So that's going to give us the square root of 8 squared. We probably could skip this step in the future because you should know directly that the square root of 8 squared is going to give you 8. So this gives me a rational answer. 28 times 8 is 224. This next example should be even more obviously rational because I'm taking an irrational term and I'm squaring it. That means that everything inside the bracket is going to be squared. That's 3 squared multiplied by the square root of 2 squared. 3 squared is 9, and the square root of 2 squared is 2. So 9 times 2, that's 18. Be careful, because although when you square a square-rooted value, it becomes rational, when you cube a square-rooted value, it does not rationalize that value. For example, 5 root 3 to the power of 3. It's generally easiest when you've got a power to simply rewrite what's being squared or cubed out. So I'm going to write that as 5 root 3 times 5 root 3 times 5 root 3. Here I can clearly see that I'm multiplying 5 times 5 times 5 and root 3 times root 3 times root 3. So that gives me 5 cubed times the square root of 3 cubed. Now the square root of 3 cubed will not give me a rational number, but I could split 3 cubed into 3 squared times 3, and 3 squared can be square rooted. The square root of 3 squared is 3. However, that extra 3 is going to remain irrational under that square root sign. So that's going to be 125 times 3 root 3. I've got a rational number multiplied by a surd term, which consists of a rational part and an irrational part. So let's multiply the rational parts together. 125 times 3 is 375, and I'll leave that 3 under the square root sign. So 375 root 3 is our answer. Coming back to our surd divisions, or surd fractions here, sometimes the division doesn't work out to be a rational answer. However, if your answer results as a fraction, you must at least make sure that the denominator of the fraction is rational. So let's give this one a go. 8 root 15 divided by 12 root 3. Let's write that as a fraction. That's 8 root 15 over 12 root 3. Splitting that across into 2 fractions, so I've got a rational fraction and an irrational fraction. I can simplify the rational fraction by dividing both top and bottom by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. That's going to give me a fractional answer of 2 over 3. And my irrational fraction could simply be divided out. 15 divided by 3 is 5. So that would be the whole number 5. There's no denominator. So my fraction 2 over 3 multiplied by my irrational part, root 5, is 2 root 5 over 3. So I've got a fractional answer. However, there is no irrational part in the denominator. So I'm perfectly happy with that answer. That is a simplified surd fraction. This fraction, however, may not simplify out so nicely. 8 root 6 divided by 16 root 14. Let's write that as a fraction. That fraction could be split off into rational parts and irrational parts. The 8 and the 16 could both be divided by 8. 8 divided by 8 would be 1. 16 divided by 8 would be 2. And the irrational parts of my fraction, 6 and 14 could both be divided by 2. 6 divided by 2 is 3, and 14 divided by 2 is 7. That gives me 1/2 and the square root of 3 over 7. If I want to join those two fractions back together, I would do 1 times the root 3 on top and 2 times the root 7 on the bottom. I've got a single fraction, however, this fraction's got an irrational value in the denominator. Remember, to get rid of an irrational number, we could multiply it by itself. Squaring surds will make them rational. But in a case like this, I don't need to multiply the denominator by 2 root 7. I just need to multiply the denominator by the root 7, the irrational part. But remember, to keep our fraction equivalent, if I multiply the denominator by root 7, I must also multiply the numerator by root 7. So root 3 times root 7 in the numerator will give me the square root of 21. And 2 root 7 times root 7 made that root 7 rational. It gave me 7. So I've got root 21 on the top, and I've got 2 times 7 on the bottom, which is 14. So there's my simplified surd fraction. I've got a rationalized denominator of 14, and that's fully simplified. Time for some practice now. So for part A of this practice exercise, I want you multiplying and dividing these surd terms together. And in part B, I've already given you some surd fractions. However, you need to make sure that the denominators of these surd fractions are rational. Go ahead and hit pause so you can copy those questions down. Go ahead and work through your answers and hit play when you're ready to take them up. I hope you had a chance to hit pause, because here come your answers. For part A, question 1 is just 5. Question 2, question 3, 4, 5, 6, 7, and 8. And for part B, rationalizing our denominator, so how did you do? Hopefully you found this lesson helpful and interesting. If you had any problems or made any mistakes, or you think I've made any mistakes, please let me know down in the comments section. Otherwise, well done, keep practicing, and I'll see you soon.